topic of my deliberation for today is assumption of erect posture and anatomical modifications which have affected due to assumption of erect posture. So now, from physical point of view, human beings came to be known as man when he could perfectly stand erect and walk bipedally. So, when he started walking bipedally in a perfect erect posture, a number of modifications took place on the skeleton, both in the axial skeleton as well as appendicular skeleton. Now, the primates is the order in which human beings or Homo sapiens scientifically called belongs to. And the primates have different mode of locomotion. When we say primate, it covers the monkeys, apes and man. So the locomotion pattern of the primates differs from species to species. Well, no doubt. Basically, we said that primates are arboreal inhabited. That means they live on the branches of the tree, move from one branch to another branch. But the higher primates, some of the higher primates, they come down on the surface of the earth and they walk bipedally or quadrupedally. So, just looking from the locomotion pattern, we can broadly divide primate locomotion into different types. One is brachiation. So, when we say brachiation, it simply means moving from one branch to another branch by swinging of the arms, leaving another arm free, and then swinging and holding the another branch with another hand and leaving the first hand again. So this process is called simply brachiation. Then again we have leaping type of movement on the trees. Here it is the rapid extension of upper and lower limbs and moving up on the tree trunk. Then we have arboreal quadrupedalism, walking on the branches of the trees or tree trunk using all the four limbs. That means 2 upper limbs and 2 lower limbs. So that is arboreal quadrupedalism. Then some other higher primates, they come down on the surface of the earth or they walk on the ground, and that is what we call as terrestrial habitat. And in this terrestrial locomotion pattern, we have terrestrial quadrupedalism. Walking on all fours, all the 4 limbs, the upper 2 limbs and the lower 2 limbs are used for walking. And then again, we have semi-erect posture, as you might have seen among the apes, particularly say chimpanzee or gorilla. They cannot stand perfectly erect and walk. However, they imitate to stand erect, but with their back little bit bent, a drooping head. So that pattern of locomotion, we call it as Clinograde posture or semi-erect posture in simple language. Then comes the most important one, that is orthograde posture, which we call it perfect erect posture and walking bipedally. That is orthograde posture. So the change from this pronograde, that means terrestrial quadrupedalism, to orthograde posture, pronograde to orthograde, that means from terrestrial quadrupedalism to terrestrial perfect erect and bipedal walk. During this process, a number of changes took place in the skeleton. So first of all, let us start with those changes which have occurred on the skull of man due to assumption of orthograde posture. That means perfect erect posture. So this is a skull. This is a human skull. And this is the skull of a chimpanzee. And again, this is the skull of a monkey. Now we will be able to see the distinct differences among these three because of assumption of erect posture. Now, this hole is called foramen magnum. This foramen magnum is a hole which connects the brain with the spinal cord, which passes through in the middle of the vertebral column. So this foramen magnum is perfectly in 6 o'clock position. If you just look a clock, a wall clock, you know the position of 6 o'clock position. So this foramen magnum is in a 6 o'clock position. That means perfectly facing downward, perfectly at the base of the skull. Whereas when we orient this skull of chimpanzee in its anatomical position, the foramen magnum is here, it is at 8 o'clock position. Whereas for man it is at 6 o'clock position, like this. And for just chimpanzee, apes and monkeys, it is at 8 o'clock position. You can just see the foramen magnum. It is at 8 o'clock position because the face is not to be kept like this, it is to be kept like this. So it is at 8 o'clock position. So this is one change, a great change which have taken place in the skull of man. Well, then at the same time, with the assumption of erect posture, the position of this occipital condyle, this is what we call as occipital condyle. Similarly, it has occipital condyle. This has also occipital condyle. So the position of occipital condyle also shifted along with the shifting of position of foramen magnum. So this occipital condyle is basically meant for articulation with the atlas vertebra of vertebral column. Atlas vertebra is the first vertebra or the first neck vertebra which articulate with the skull. So the position of occipital condyle also changes. Then here in human skull, the jaw, that means the maxilla and mandible, it is almost in the same line with the face. That means it does not project out. You see the bone of a monkey. It is not to be kept like this. It is the anatomical orientation. Here the jaw projects out, the maxilla projects out. Similarly, you see here also it is anatomical position and the upper jaw or maxilla projects out. Similarly, the mandible also projects out. So here it is more or less vertical. Why? It is because the jaw is smaller in size as well as it recedes. So when the jaw comes out like this, the center of gravity changes from the middle to the frontal side. So it naturally tends to droop down like this. But now as human beings or as mankind stand erect or attain perfect erect posture, this recedes and center of gravity is well maintained in line of the body. So it's a very important distinction that we should make in the skull of apes and man, particularly due to assumption of erect posture. Now, this is a mandible, a lower jaw. And this curvature, we call it dental arch. And this dental arch, if you simply look at it, Which alphabet it resembles? It resembles V-shaped, not U-shaped. Among the apes and monkeys and other lower primates, it is not V-shaped. We also call it as parabolic shape, no doubt, but it is not V-shaped, it is rather U-shaped. Here it is V-shaped. This is another change, another anatomical modification that we have observed due to assumption of erect posture. Why it expands here? Because you see the cranium, the brain size increase. So in this skull, this part is called cranium, this part is called facial region. So the cranium expands because of increased brain size. So when the brain size increase, the condyle of the jaw also expands. So expansion of condyle forming a V-shaped or parabolic curve of dental arch is another change that we have noticed in man due to assumption of erect posture. Then you see, here we can see a rough ridge. This is called knuckle ridge. What is this for? This is simply meant for fastening the muscle which arises from the neck. Why fastening? So that the head doesn't droop down like this. So when it tends to droop down like this, if muscles pull it down, then it is perfectly kept in a vertical position. But in case of men, what happened? The knuckle ridge, which is meant for fastening the neck muscle, is no more prominent on human skull. Why? Because the skull doesn't droop down as it is well balanced on the atlas vertebra. However, among the other primates, apes and the monkeys, this knuckle ridge is very prominent. Why? Because the jaw projects out, the face projects out, naturally it tends to droop down. So in order to make it not droop down, the neck muscle fasten it here and pull it off in such a way so that it also maintains its facial position. So that is another anatomical modification that has occurred in human skull due to assumption of erect posture. Now, facial region has reduced comparatively from the cranial part. The facial region is reduced. Proportionally it is reduced as compared to the cranial part. So this cranial part is very large and this facial part is reduced. Here, among the monkeys, the cranial part is comparatively smaller and facial part is comparatively larger. Why? Because the brain in human beings or mankind is larger than that of the apes and monkey. So the brain cavity naturally is small in apes and monkeys and large in man. So correspondingly what happened? The facial part diminishes in size for man and it retains its large size among apes and the monkeys. Now, you see, we have this supraorbital ridge. You can see a very, very prominent supraorbital ridge, or commonly we call it eyebrow ridge. So this supraorbital ridge is very, very prominent here. Similarly, here also it is very prominent. This supraorbital ridge is not meant to guard the eyes, but it is meant for fastening of muscles which arose from jaw. Because jaw is very heavy, as I told you, it's massive in size. Just to fasten the muscle which arose from the mandible, the prominency is required. But what about men? In men, a lower jaw and the maxilla, that means mandible and maxilla, are no more large. They are comparatively reduced in size, as I told you, receding. Therefore, there is no necessity of having a large supraorbital or eyebrow ridge. You see, no eyebrow ridge, almost absent, or maybe even if developed, faintly developed. Here, the supraorbital ridge is very prominent. So this is again another landmark or important change which has occurred with the assumption of erect posture. When supraorbital ridge is prominent, along with it, this is mid-sagittal crest. This crest is again meant for fastening the muscles of jaws, so that the jaw doesn't hang down freely. So this mid-sagittal crest or a temporal crest, they are no more visible on the skull of human being. No mid-sagittal crest. Here you can see mid-sagittal crest. So this mid-sagittal crest is absent. So that is another modification which has taken place on human skull due to assumption of erect posture. When the jaw has reduced in size, this is human mandible, human jaw. When the jaw has reduced in size, correspondingly, the teeth embedded inside the jaw also reduce in size. So this helps in lessening the weight of the mandible again. So when the weight of the mandible is less, then there is less chance of drooping down. So this is again another change which has occurred on the skull due to assumption of erect posture. So skull is not the only bone on which anatomical modification has taken place due to assumption of erect posture. Considering the axial skeleton means that part of the skeleton which forms the axis of our body. So when we say axis, we remove the limb part. That means the forelimbs and hind limbs are taken out from the total of the skeleton. Then the remaining part forms the axis of the body. So skull is one. Then vertebral column is one. Then sternum is another. And ribs, what we call rib cage. So that those ribs constitute axial skeleton of our human body. Now, a major change took place on the skull due to assumption of erect posture, no doubt. But changes are also noticed on the vertebral column of human body due to attainment of erect posture. Now vertebral column, this is the vertebral column. So altogether in a vertebral column, there are 33 vertebra. So these 33 vertebra together constitute vertebral column, or we simply say it as spine. Now what happened? These 33 vertebra are all together lined up, forming S-shaped structure, the alphabet S in human being. This vertebral column can be divided into 5 sections. The first one is cervical part. Cervical part means neck region. So there are altogether 7 bones or 7 vertebrae constituting neck region or cervical vertebra. Then 12 of them constitute thoracic vertebra. Then another 5 comes in abdominal region, and that is what we call as lumbar vertebra. Then another 5 constitute sacral vertebra, and remaining 4 constitute coccyx or coccygeal vertebra. There may be some variations, but in general, altogether, number of bones or number of vertebra for a vertebral column is 33. So this vertebral column experiences a change with the assumption of erect posture. So the vertebral column of apes and monkeys, structurally they are bow-shaped, because while they walk semi-erect. Semi-erect posture is such a posture in which the legs are bent little bit, then the trunk is little bit drooped down, and arms hang down freely on the front. But in case of human beings, what happened? It doesn't droop down, and hands means the arms, including our palm, hangs down freely on the side of the body. The bow-shaped vertebral column of monkeys and apes naturally makes them droop down, little bit bent. But in case of men, due to the assumption of erect posture, the shape of vertebral column changed. It is no more bow-shaped because head is well balanced on the atlas vertebra, the first vertebra. This is the atlas vertebra, the first vertebra. So it articulates with the occipital condyle located near the foramen magnum. So it is perfectly balanced on this. So that is why it need not droop down. If we just compare the shape of vertebral column with an alphabet, it resembles S. Why it is S shape? Because it acts like a spring. So when the weight is loaded from above, it tries to droop down like on this side. Then when it tries to droop down from on this side, the curvature on the vertebral column makes it come back like this again. When it tries to move down this side, the another curvature again makes it bring this side. So this system, it acts simply like a spring. So that is why it is S-shaped. This is one major change which we have noticed on the vertebral column of man due to assumption of erect posture. Another change that we have noticed is the back side of the vertebra possesses a spine. So this is a spine. This is another spine. So this is spine. These are all spine. So these spines are comparatively very much reduced in length as compared to those of apes and monkeys. Why it is reduced? Because the muscle which arose from this gets fastened at the knuckle ridge. The knuckle ridge, which is the ridge found on the back side of occipital bone or posterior surface of occipital bone, just above foramen magnum. So the fastening of that muscle helps in controlling the drooping down of head. So in case of men, as the skull is better balanced, or rather we can say well balanced on the first vertebra, at last vertebra of cervical vertebra, there is no need of a very, very strong fastening. So that is why these spines are comparatively reduced in length. So this is one point. Then this, as I have told you, this part we commonly call it sacrum. So this is the last part of the vertebral column, but if we just examine it, it has two sections. One is sacral part, another coccyx. Sacral part 5 bone and coccyx 4 bones. So the 9 bones fuse together to form this sacrum. So this is the last part of the vertebral column. That means caudal part. We call it caudal part. So this is comparatively broad. This is comparatively broader and shorter. Why broader and shorter? It articulates with the hip bone, pelvic bone. This is one bone, pelvic bone. This is another bone. So it articulates like this. You see, this is the position. And this forms something like a veshing. Why? Because the internal viscera, the pelvic viscera, all those intestine and other things, they are to be supported by this. Because man stands erect. In case of other animals, particularly other primates, apes and monkeys, they are not vertical in position. They have either this drooping like this, their trunk bent down. But in case of us, we stand erect. So all the viscera are to be supported by this pelvic veshing. So that is why it needs to be broader, so that the viscera can be easily supported. And it has a curvature forward curvature, or rather let us say from scientific term, a concavity forward, facing towards the front. So the cervical vertebra, those 7 vertebrae of neck, that is having a convexity forward. I told you there are 4 curves forming an S-shaped structure. So the cervical vertebra, neck vertebra, it forms a convexity. Then thoracic vertebra, cervical neck region forms a convexity, thoracic a concavity. Then lumbar, abdominal part, a convexity, and this coccygeal part or sacrum part, again a concavity. So this convexity, concavity, convexity, concavity, 4 curves which acts like a spring. So these are major changes which we have noticed on the vertebral column of man, by means of which man can perfectly stand erect and walk bipedally, differentiating itself from other primates and making him known as man.